Okay, so one of the things you're going to have to be able to do is draw an electrochemical cell, and part of that will be to identify the anode and the cathode. And in order to do that, you need to know what's occurring in each one. So the anode is where the oxidation occurs, and the cathode is where the reduction occurs. And one easy way to remember that is to remember these mnemonics. And one is anox. And anox, you can think about an ox. An anode is where the oxidation occurs. Okay? And red cat is where the reduction occurs at the cathode. Red for redox, cat. And you can also think overall of fat cat. And a fat cat is where the electrons in the voltaic galvanic cell flows from anode to cathode, or fat cat, from anode to cathode. Hopefully those will help you remember. Alright, so on the back of your periodic table you will see a table of standard reduction potentials. Now these are just reductions, they are not oxidations. So they're listed from high to low reduction potentials. So in order to figure out how much voltage is being generated from a cell, electrochemical cell, galvanic cell, you need to be able to read this table. So they're all written as things that gain electrons, because that's what reduction is. They're not written as oxidation. So the things that are going to most easily lose electrons are actually down at the bottom, which is why it's a negative value, because those things like lithium are most likely to be oxidized. Okay, they're not going to gain electrons, they're going to lose electrons. Okay, so the way this table is constructed is that all of these values are compared to hydrogen, which is the standard right here at 0, 0. So the reduction for hydrogen is 0, 0, and all other values are compared to that of hydrogen. Okay, so those that have a greater reduction potential are positive, and those that have a lower reduction potential than hydrogen are negative. So when we think back to that zinc and copper electrochemical cell, and we look the values up on the table, this is what we get. We get zinc reduction is minus 0.76, pretty low on the table, and copper's reduction is 0.34. So the more positive or the less negative, the more favorable that reduction potential is. Okay? So therefore, the value that's the greatest is the reduction of copper. So copper is going to stay as my reduction. Now I have to change what happens to the zinc here to be my oxidation. So what I'm going to have to do is I'm going to have to take this zinc reaction and flip it and change the sign. So when I do that, I cross off the reduction, I change it to an oxidation, and I change the sign from a negative 0.6 to a positive 0.6. And then in order to get the overall cell potential, what I have to do is I have to add them together. So I'm going to add the E naught, and naught, here E naught means standard conditions, okay? Remember from earlier, that's 25 degrees C, and in the case of an electrochemical cell, we're talking about 1 molar solutions of the ionic compounds that are in each of the individual compartments of the cell. Okay, so if we have those standard conditions, 25 degrees C, and we have 1 molar solutions of the aqueous compounds, then these are the E naught of the cell. And so this cell with zinc and copper will have an overall voltage of 1.1 volts. Now the other thing you need to be familiar with is what's known as the line notation and how an electrochemical cell might be written. So for instance, this electrochemical cell with zinc and copper, what I have to do is first write what happens in the anode, and because it's anox and the zinc is being oxidized, I put the zinc first. So I always start with the metal, and then I start with what's happening, is going from zinc metal to zinc plus 2. I put a double line. You can think about this as being where the salt bridge is, and then I show what's happening at the cathode. and things are going from, the copper's going from +2 to copper. Okay, so if we see a line notation like this, it won't say anode and cathode. What we have to know is this is going to be where the oxidation occurs, this is where the reduction occurs, this is going to be the salt bridge, and these are the components of the sample. Now this actually shows a different molarity for the cathode, so this is not going to be E0 because it's not at standard conditions. Okay, so we're going to stop right there.